Okay, continuing our solving radical equations, instead of looking at square roots now, we're going to look at cube roots. So you're going to solve it the same way, use the same method, except when we get to the end, we're going to be cubing both sides instead of squaring both sides. Again, you want to do the inverse operation. So if I have a cube root, to cancel that out and to negate that, I need to do the inverse operation, which is to cube it. So let's look at the first example. I have the cube root of x minus 8 equals negative 3. I don't have any extra numbers, any constants added or subtracted. I don't have any constants in front, I guess, which would be your a value if you were looking at graphing this. So I can go straight to the cubing. So I'm going to cube, which means to the third power, both sides. When I cube both sides, again, these are inverses, inverse operations. So cube and cube root will cancel each other out. That leaves me with x minus 8. If I take the cube root of x minus 8 and I cube it, that's just going to give me x minus 8. That's like squaring a square root. They negate each other. If I cube negative 3, I get negative 3 times negative 3, which is positive 9, times negative 3, which is negative 27. So now I'm just solving for x. So I'm going to add 8 to both sides. So x equals negative 27 plus 8, and that gives us negative 19. So that is your final answer. If I were to plug negative 19 in for x and substitute, I would get negative 19 minus 8, which would give me negative 27. And the cube root of negative 27 is indeed negative 3. That's how you can check your answer. So let's look at the next one. In number 2, I have the same situation I had in the previous example when we did square roots, where now I've got something added on and I have an a value. So I'm going to have to do a little bit of manipulation with the equation before I can actually get to the cubing. So the first thing I'm going to do is I'm going to take this value here, and I'm going to subtract it from both sides. Since it's a positive 2, I'm going to move it over. And that's a 5, by the way. That's a positive 5. So that gives me positive 5 times the cube root of 3x plus 4 equals negative 25. And remember, that 3, that's called an index. With square roots, sometimes they'll write a 2, but most of the time you don't see it. It's understood that it's a square root, it's a 2. But for other roots, third root, fourth root, quartic root, fifth root, you will actually see the index written here. So the next thing I'm going to do is I have to move that 5. And since it's 5 times the cube root, I can divide both sides by 5. It's 5 times this entire value. So I'm going to divide this out, and that's just going to leave me with the cube root of 3x plus 4 equals negative 25 divided by positive 5, which is negative 5. So far, I've now moved the 2 and divided both sides by the a value, or the 5. So now I'm ready to cube both sides. So I'm going to put both sides to the third power. I'm going to cube both. And remember, inverse operations, cube root, cube, cancel each other out. So 3x plus 4. And when I cube negative 5 times negative 5 is positive 25. Positive 25 times negative 5 is negative 125. So now I'm just ready to solve. So I'm going to move the 4, subtract the 4. So I've got 3x equals negative 129. Now, this is a big number, and I once showed you a trick on one of the other videos. I've got a 3. How do I know if a number can be divisible by 3, if it can be divided by 3 or 9? Well, if you add the numbers together of your value and all of the digits add up to a multiple of 3, it can be evenly divided by 3. So as ugly as 129 looks, 1 plus 2 is 3, plus 9 is 12. 12 is a multiple of 3, which means 3 will divide evenly into negative or into 129. So I'm going to divide both sides by 3. Negative divided by positive gives me a negative. And you get 43. So your answer is x equals 43. And that's how you solve equations with radicals with cube roots.